Hello, Faiz. We are here from Group 6. My name is Divasya Irawan. I'm here with my friends Zaki, Erina, and Fadel. And we are going to explain about Pumped Storage Hydropower System as one of the implementation of physics electric in our daily life. Next. And here is the contents we will explain more later. So what is pumped storage hydropower? So it's basically a method of energy storage for hydroelectric power plants, and it's also a system that uses two water reservoirs at different elevation, higher and lower, and it produces electricity as water flows down from one to the other through a turbine, and it pumps the water back into the top reservoir, requires the use of electricity. And the system have two modes, generating modes and pumping mode. Next.
So why is the PSH needed? So when transitioning to a greener and more sustainable energy, it comes with its own problems, such as the first one is unpredictable energy generator. And the second one is high variability between peak demand and low demand of electricity. So take solar energy as an example. During maybe rainy season or maybe during the night, the energy production of the solar panels are significantly reduced since the solar panel cannot receive most of the energy from the sun because it is blocked by the cloud or maybe when it's night. So here's one of the problems. The duck curve is a popular term referencing to the shape of the fossil fuel generated electricity during any time of the day, shown in the following graph. Since the solar energy can only produce electricity when the sun is up, the energy generated during the night is mostly from fossil fuel generators. That's why we need the energy storage systems in order to decarbonize the electric grid and move towards renewable and sustainable energy so that they can use them during the night.
This is how hydropower system stores energy. The first step is the renewable energy, such as wind or solar, is used to pump water uphill during the times of low demand. And the second step is when the demand increases or when our solar production drops, water runs downhill from upper reservoir. And the third step is the water runs through the turbine, creating electricity. And then the last step is the more stable, less variable supply results from adding electricity from turbine to original renewable power.
And this is how the flow of water generates electricity. As you can see, the image shows the flow of the system, and the right one, it is the generator of the system. So a hydroelectric generator converts this mechanical energy into electricity. The operation of a generator is based on the principle discovered by Faraday, and he found that when a magnet is moved past a conductor, it causes electricity to flow. In a large generator, electromagnets are made by circulating direct current through loops of wire around stacks of magnetic steel laminations. These are called field poles and are mounted on the perimeter of the rotor. The rotor is attached to the turbine shaft and rotates at a fixed speed. When the rotor turns, it causes the field poles to move past the conductor mounted in the stator. This in turn causes electricity to flow and voltage to develop the generator output terminals.
This is the application of pumped storage hydropower system. A pumped storage hydropower system could be implemented in a lot of countries in the world, especially in Asia, because we offer a huge number of hills and rivers. PHS could be used for approximately 50 years, and if there's no rivers around, we could use a reservoir. And the maximum power that the reservoir could provide is 5 to 25 hours.
Now I'm gonna explain the advantages of hydropower system. The first one is hydropower is a renewable source of energy because they relies on the water cycle, which is driven by the sun. And the next one is clean source of energy. Hydroelectric power won't pollute the air like power plants that burn fossil fuels. And hydroelectric power is flexible because some of hydropower facilities can quickly go from zero power to maximum output. The next one is hydropower is affordable and as other renewable energy sources because they store energy used in tandem with renewables such as wind and solar power. Next. So here are the disadvantages of hydropower system. They have environmental impacts. Hydropower facilities can affect land use, homes, and natural habitats in dam area, and also causing changes in reservoir and stream water quality. They also can disrupt wildlife habitat and lead to the entrapment. And hydroelectricity is hydrology dependent. The system depends on the precipitation levels, which can fluctuate from year to year, causing instability. So there are also the pros and cons summary that study also reveals that the positive and negative effects are not being adequately examined in the hydropower relicensing process. Outlines opportunities to reduce the negative environmental impacts of hydropower without significant economic drawbacks.
So here is several other energy storage systems. It is divided into 5 categories. The first one is the chemical energy storage. And here is some of the examples: biofuel, hydrated salts, hydrogen storage, and hydrogen peroxide. The second one is a thermal energy storage system. For example, ice storage, air conditioning, and brick storage heater. And the third one is mechanical energy storage, which includes pumped storage hydroelectricity and compressed air energy storage. And the next one is electrochemical energy storage. For example, flow battery, rechargeable battery, and ultra battery. And the last one is electrical energy storage. For example, capacitor, supercapacitor, and superconducting magnetic energy storage system.
In conclusion, transitioning to green and sustainable energy requires efficient energy storage systems. And also, Indonesia is a great place to implement pumped storage hydro system because we have a lot of hills and rivers. All in all, PSH is one of the implementation of physics electric in our daily life since it requires a hydroelectric generator in order to convert mechanical energy into electricity. Based on Faraday's principles, the magnet moves past a conductor, causes electricity to flow at the generator output terminals. Here are the references that we used during making this presentation. And that's all from us. Thank you.